In this video, I want to show you an example of solving a two-dimensional kinematics problem. So we have a simple case here. Object starts with a velocity 7 meters per second pointing east. When it experiences an acceleration 3 meters per square second in the direction 30 degrees north of west, what is the object speed after 5 seconds? Okay, so step one, identify the initial and final states clearly. Make sure you know what problem you're solving. Okay, so the question tells me here the object starts with a velocity 7 meters per second pointing east. Okay, so that's my initial state clearly. So here's my object, and it's going in this direction. I'm using the standard north, south, east, west, and this is 7 meters per second. And it experiences an acceleration 30 degrees north of west. So the acceleration vector is going to be in some direction like this, with a 30-degree angle here because it's 30 degrees north of west. So I start with west and go 30 degrees north of that. So that's the acceleration. And I want to know what's the object speed after 5 seconds. So I don't really know what the final state is. It's going to have some other velocity in the final state. I'm not quite sure. It's definitely going to be going up somehow in the final state. It could be going up and right, or it could be going up and left. I can't really tell whether enough time has elapsed for this acceleration to actually turn it around or not. But, you know, so maybe it might do something like this, or maybe it actually looped around like that, and now it's going in this direction. So it's going to be one of those two possibilities. So I don't know if the x component of the final velocity should be positive or negative, but I do know the y component should be positive. So the final state will be something like that. All right, so I've organized my thoughts about this problem. Next thing I need to do is identify the nodes. And again, this is a key point for going to 2 dimensions. I'm now doing this process twice, once for the x and once for the y. And these, I need to keep these separated from each other. So let me reread the question here. An object starts with a velocity 7 meters per second pointed east. That's clearly the initial velocity. The initial velocity is pointed east. So I'm going to have Vox is positive 7, because I'm going to make positive x direction equals east. Now, don't forget, we know the x component of initial velocity is positive 7. We also know the y component of initial velocity, because if it's pointing east, that means it doesn't have any y component. So don't forget, we also know Voy equals 0. It still counts as a known just because you know it's 0. Okay, next, it has an acceleration, which is given down there, 3 meters per square second, 30 degrees north of west. So that means I can break that vector into components and get an x component and a y component. So I need to do that. The x component is negative, the y component is positive. I can see that if I turn this into a right triangle here, the x side is over here, the y side is over here. So the x side is adjacent to the 30-degree angle. So this is going to be 3 cosine 30. Just not writing the unit there just to save space. 3 times cosine 30 equals 2.6 minus 2.6, because I need that negative sign in there as well. And the y component of acceleration, that's going to be 3 times sine of 30, which I believe is 1.5. Just make sure. Yes. Sine of 30 is half, so this is positive 1.5. Okay. What else do I know? I know that 5 seconds elapse between the initial state and the final state. So how do I break that down into x and y directions? Time is the one case where it's the same for x and y. So I can actually, if you want to stick to this 2-column method, which personally helps me a lot, I'm going to write time in both columns. I'm just going to write it twice to remind myself that that applies to both directions. So that's the time in the x direction. It's also the time in the y direction because time is time. Now, I feel very happy right now because I have 3 knowns in the x column and I have 3 knowns in the y column. I'm in great shape here because 3 knowns is what I'm looking for. Now I want to identify what's my unknown. The unknown here is the object's speed. And note that it says speed and not velocity. Speed is the magnitude of the final velocity vector. To find the magnitude, I'm going to need to know both components. And then at the end of the problem, I'm going to do the speed is the square root of x squared plus y squared to get the magnitude. So I'm going to need to know VFX as my unknown for x, and I'm going to want VFY as my unknown for y. So there's my 4 variables. In this case, it's actually the same 4 variables in both columns. That's not necessarily always the case, but in this case, I'm going to choose the same equation for each column. The only thing that's modified is the subscripts to take into account that one is for x and one is for y. So if you consult your list of 5 kinematic variables and then look at which one contains these 4 variables, and I want the one that does not contain delta x. So that's going to be, the formula is going to be, let me write it over here. The formula is going to be VF equals VO plus AT. And when I actually apply that here, I need to put all x subscripts when it goes into this column. And I need to put all y subscripts when it goes into this column. Okay, so there's my equation that I want to use for both cases. Now I just plug. So VOX, that's 7, plus AX, that's negative 2.6. Time is 5. So it's 7 minus 2.6 times 5. 7 minus 2.6 times 5 is negative 6. So it turns out it actually did have enough time to turn the whole thing around and reverse the direction of the initial velocity. Okay, and then in the y direction, I'm going to have VOY is 0, AY is 1.5, and T is 5. So VFY is just going to be 1.5 times 5, which is 7.5. So positive 7.5. And incidentally, then, like I was talking about, conceptually, that means the actual final situation is not that, oh, what is that? There. The actual final situation is not this one, it's this one, where the object must have had some path like this that actually turned it around and made the x component of velocity negative, but the y component is positive. Okay, last, I need to use this idea to calculate the speed from the final velocity. Let me just make a little bit of space here. Okay. So then the last thing I need to do is that the final velocity is equal to square root 6 square plus 7.5 square, which once again, I just dropped the negative sign because it's about to get squared anyway. So you can write it in there if you want to, but you have to square it out. It's inside the parentheses if you write it. And this gives me, I got 9.6. 9.6 meters per second. And the question only asked for the speed. So you could also find the direction of the final velocity vector if you drew it and did tangent to find the angle if you were so inclined. But the question actually just asked me for the speed, so I'm done. So notice that I followed the same procedure I outlined before, the only difference being that I did it twice. Once for the x column and once for the y column, which means you need to break everything into components. That's the key idea.